Welcome back to math class. The last few sections in this chapter have been different kinds of transformations. If you remember, we did reflections, and then we did translations, and then we did rotations. Today we're going to talk about compositions of transformations. What we're thinking when we're thinking compositions, you could almost think of like a compound transformation. We're doing two transformations at once instead of just one at a time like we have been doing. There are two types of composition transformations that we're going to be learning about in this chapter. We're going to do one today and one tomorrow. So the one today is called a glide reflection. Glide reflection. Now you already know what a reflection is, right? It's when we flip something over a line. Glide is referring to a reflection that flips over a line and moves along a translation vector. So we're going to take our original image, we're just going to call it a translation of that original image, followed by a reflection over a line parallel to the translation vector. Now your book gives a really good example of this that I'm not going to try to draw because I'm not very good at drawing feet. But they use the example of footprints. A footprint, you'll have one foot, and then it'll slide forward and then reflect across for your other foot. We'll have a shape, I'll just use a triangle, right? Now, first things first is I'm going to move along a vector, draw my same triangle along this vector. I didn't measure, so it's not exactly perfect, and then reflect it over your translation vector. And that's your new shape. So it's first moved along your translation vector and then reflected down across the line. Now what this means practically speaking, as we're having to graph them, is you're going to have to remember back to both of those lessons and do it one at a time. So for example, you might see a problem that says, here's a triangle PQR. Point P is at 1, 1. Q is at 2, 5. And R is at 4, 2. Then it's going to say, give me a translation. A translation with a vector of -2, 0 that has also been reflected over the x-axis. Reflected over the x-axis. So just like on your homeworks, we're going to draw a graph and we're going to graph our original shape first. So let me make my graph. So there's my graph, and I'm going to graph point P, which is 1, 1. There's P. Q is going to be 2, 5. So 1, 2, 1, 2, 3, 4, 5, all the way up here. Q. And then R is 4, 2. So I'm going to go 1, 2, 3, 4, and up 2. There's R. So here is my original triangle, P, Q, and R. So first things first, I'm going to give it a translation with the vector -2, 0. Now we know from our section on translations that how I'm going to do that is take our coordinates for P, Q, and R and translate them 2 spaces to the left. And I'm going to do that by going P prime equals 1 minus 2, 1 plus 0. Which means it's going to be -1, 1. That's our P prime. Our Q prime is going to be 2 minus 2, 5 plus 0. Let me give myself a little more room here. I'm going to box these off. And that's going to be 2 minus 2 is going to be 0, and 5 plus 0 will be 5. So our Q prime will be 0, 5. And our R prime is going to be 4 minus 2 and 2 plus 0, which is going to give us 2, 2. Okay, so now we're going to graph our P prime. This is with our translation only. It's going to be -1, 1. There's P prime. Our Q prime is 0, 5. And then our R prime is 2, 2. I'm actually going to connect it with a different color so you guys can see. Tell them all apart. There's my Q prime, my P prime, and my R prime. Okay, there's our second triangle. But we're not done because it doesn't ask just for a translation. It also asks for a translation that is then reflected over the x-axis. So you guys might remember to reflect something over the x-axis, I take my original coordinates, which look like this, x, y, and I rewrite them to be x, well here. Yeah, I'm going to rewrite them as x, -y. Okay, I'm going to erase this so that I have room on the board to write. So basically, we're taking our P prime, our Q prime, and our R prime, and we're reflecting it over the x-axis. So I'm going to go through and I'm going to make all the y values negative. I'm going to go our P double prime, this is our second time translating it, or transforming it, it's going to be -1, because our x stays the same, and then -1, because we've made our y negative. Our Q double prime is going to be still 0, because our x's didn't change, and -5, because our y value is negative. And our R prime, or our R double prime, is going to be 2, stays the same, and -2. Okay, now we're going to graph these points. So my P double prime is at -1, -1. This is our P double prime. Our Q double prime is going to be 0, -5. So we're going to stay at 0. Go to -5. There's our Q double prime. And our R double prime is 2, negative 2. So I'm going to go over 2 and down 2. That's our R double prime. Then I'm going to connect my dots. Okay, so this is our final triangle. This is taking our original triangle, translating it along a vector, and then reflecting it over the x-axis. Essentially, this is our glide reflection along that vector over the x-axis. A composition transformation had 2 steps: translation, then reflection.